I'm Anil Kumar. Let me thank all the members of our Free Math Solutions WhatsApp group for participating actively. You have been posting brilliant questions and also helping to provide excellent solutions. Here is another beautiful question which I would like to share with all of you, and I hope its solution will help many others. Now, this is a question which we'll have noted down here and we'll talk about it in details. I'll solve this question using some basic properties that should help even to get quick solutions to such questions. It is based on coordinate geometry, and if you know the line division formula, it is very simple to do. We'll actually derive this formula in this video also. The question here is, a giant kite is constructed using bamboo for the edges and diagonals and card for the sail. When mapped on a diagram, the ends of the long diagonal are at P 2 minus 2 and B minus 14. It was probably PQR. Let me make it up. And R minus 14 minus 14. And the diagonals intersect at M. The short diagonal QS divides RP in the ratio of 3:1, so that is R and P. And MP equals to MQ equals to MS. Calculate the coordinates of M, the coordinates of Q and S, the equation of diagonals, the equation of sides of the kite, the area of the card needed to make the kite, and total length of the bamboo required for the structure. So it has a lot of stuff in it. We'll try to see how to solve such a question. We'll begin with the line division formula first, because that directly gives you the value of M. Now, since this question has come to us, I think the major problem here is to understand how do we find M, because once you get the value of M, where the two diagonals are intersecting, we can easily solve this question. So I'll actually derive section formula here. And then move on. So when I say section formula, it really means if I have a line, let me just draw a line here. So we'll use a line just more diagonal. And let us say there is a particular point here which divides this line in the ratio of M is to N, where this portion is M and that is N. Let us say that the coordinates of the point here, A, are x1, y1, and for B is x2, y2. And this is the point which we are interested in finding. Let's call this as our mid. I will use M as xy. You will notice that if I just draw a horizontal line here and a vertical line from there, then we do form two triangles which are similar. Do you see that? Let's call these points as S and T. So we have A, M, and B here. We're calling this point as S and T. Now, how much is this length, this small one? Well, that is y2 minus y, right? This length is y2 minus y. And from here to there, it is y2 minus y1. Correct? So let's work on the y's first. So what we see from here, that bigger triangle, which is, let me say, triangle ABT, is similar to triangle BMS, right? Because they have this 90 degrees. and these angles are equal. These are parallel lines, horizontal and vertical lines, right? So from here we can write that the ratio of their sides are constant, or we can say y2 minus y1 over y2 minus y is equal to, now the combination is m plus n, right? So the big triangle will be m plus n, and the small triangle side is n. We can now cross multiply and isolate y. Perfect. So when we cross multiply, we get n times y2 minus y1 equals to m plus n times y2 minus y. So let's open this bracket. We have n times y2 minus n times y1. Now here we have a term with y2, so we'll bring this term here on this side. Let's open this first. So we have m times y2 plus n times y2, and we'll keep this as minus y we need to isolate, y times m plus n. So keeping this on the left side, we get y times m plus n is equal to m times y2 plus n times y2. That becomes minus ny2, and this becomes plus ny1. So from here, this negative ny2 and positive ny2 cancel. So these are the two terms left here, and we can isolate y, which is equal to, in the numerator we have m times y2 plus n times y1 over m plus n. Is that clear to you? So using these similar triangles, we have isolated y. Correct? Now same thing you could do for the horizontal distance. Now this line here is basically x2 minus x1, and this is x2 minus x, correct? So that ratio x2 minus x1 over x2 minus x is also equal to this combination is m plus n, and that is n. So when you isolate this using exactly the same steps, you also get the coordinate points for x, which will be m times, very similar. You can just replace and do the same thing, x2 plus n times x1 over m plus n. Do you see that? So basically, you get the coordinates of point M, which you can read that m times x2, y2, and n times x1, y1 is the numerator, right? So m times x2, n times x1. So it's kind of that. So this gets multiplied with the term here, and that gets multiplied with the term here. Denominator is m plus n. So let me rewrite this formula here. That is the x value. The y value is m times y2 plus n times y1 over m plus n. So we are going to use this formula in our question, where m is 3 for us and n is 1, and these are my 2 points. You get the idea. Correct? So let's move on, and now using this section formula, we'll solve it further. So now let's continue with the solution of our question. So the giant kite is constructed using bamboo for the edges and diagonals and the card for sail. When mapped on a diagram, the ends of log diagonal are p is 2 minus 2 and b is minus 14 minus 14. It is not b, it is r. Okay, so let me sketch this diagonal PR. So let's do it like this, kind of a okay. So this point here is given to us as, we'll write P here as 2 minus 2 and R here as minus 14 minus 14. Both are negative, so I took it on the left side. The diagonal intersects at M, so there is another diagonal here which will be at right angles for sure, right? The short diagonal QS divides RP in the ratio of 3:1. So we'll say 3:1, we'll divide into 4 parts, and let us say this is your short diagonal. Okay. That says that the diagonal intersects at M. So this point right there is M. And P, Q, R, and S. So that becomes the kite. Let's complete this kite. So we have clear? So that's the kite which we have. Now what we are given here is that the ratio in which M divides is 3:1. So this is 3 and that is 1. That is what we are given to us. Now what should be the coordinates of M? That is what we need to find, right? First thing is we need to find the coordinates of M. So we are using section formula. So if it is M is to N, in that case the value of X is, we are using this as X1, that is X2. So the formula was M times X2 plus N times X1 over M plus N. And the Y coordinate value will be M times Y2 plus N times Y1 over M plus N. So for M, the points are, this is 3, right? And that is 1. And so 3 will get multiplied with 2. So it is 3 times 2. Plus 1 will get multiplied with minus 14 over 3 plus 1, which is 4, correct? And the Y coordinate will be 3 times minus 2 plus 1 time minus 14 over 4. Clear? So that is equal to what? So that is 6 and that is minus 14. So minus 8 over 4. Minus 8 over 4 is minus 2. Minus 6 and minus 14 is 20 with negative sign. 20 divided by 4 is minus 5. Is that clear? So we get the coordinates of point M, which are, let me write down here, minus 2, minus 5. So easy. So if you know the formula, it is just few seconds to get your answer. Now, let us focus on the other part, which is find the coordinates of Q and S. Now what we are also given is that these sides are all equal. These three sides are equal. MP is equals to MQ is equals to MS. Now to find Q and S, here is another strategy. Now if you look at the point M and P and M and Q, they are at right angles, correct? So this is a kite. It will always intersect at right angles. And therefore, if I say from moving from here to here, it is rise over run, it kind of slope changes, right? Okay. So if I am moving from M to P, let me write down that the slope from M to P is what? From M to P is y2 minus y1, which is, now we know what M is, right? Let me write here, minus 2 minus 5. So change in y2 is minus 2. Minus of minus 5 gives me plus 5 over 2 minus minus 2 makes it plus 2, correct? So that gives you 5 minus 2 is 3 and 2 plus 2 is 4. So slope of MP is this. Slope of MS will be what? Negative reciprocal, right? Minus 4, 3. Does it make sense to you? Because it is perpendicular lines. Correct? Now here, practically, we move from M to P by change in, this is change in Y over change in X. Does it make sense to you? So from here, the change in X and change in Y can also give us the coordinates of Q and S. You get the idea. Correct? So when I say minus 4 over 3, then really it means that from M, which is at minus 2, minus 5, we are looking for 2 points where it could be delta y equals to minus 3, delta x equals to 3, delta y is minus 4, delta x is 3. Or we could flip it. We could change in y is plus 4 and change in x is minus 3. That also gives us minus 4 over 3. Correct? So if I do that, I get the point. In the x value, if I add 3, so we get the x value, minus 2 plus 3 is the x value. And in the y value, minus 5 minus 4. That becomes 1 point. And if we go this way, the x value will be minus 2 minus 3. And the y value will be minus 5 plus 4. So that gives you what? Let me write down here. So minus 2 plus 3 gives me the value which is 1, and that is minus 9. And here we get minus 5, and that is minus 1. Clear? So we get these 2 points. So 1 minus 9, so I can write S as 1 minus 9 and Q as minus 5 minus 1. Do you see how easily we got the coordinates of P and S without even using a distance formula? Does it make sense to you? So we did not even use the distance formula and got our points from this logic. Right. So this, since it is more downwards, we are using this for S and that for Q. Makes sense. So we are going down minus 4 and on the right side 3 units. If we do the other way, which is 4 over minus 3, we get the points Q. So we get these 2 points. Correct? Now once you get these 2 points, you can find all the distances. Right? So we have our points. So let me rewrite the points which we got, which is M is minus 2 minus 5, Q minus 5 minus 1, and S, P is given to us, S is 1 minus 9. Correct? So we'll move forward with these points and do the rest of the question. Now we need to find equation of the diagonals and equation of the sides of the kite. So let me again sketch the kite which we have. Now this time we'll just sketch it with the coordinate points. So the coordinate points are P, which is 2 minus 2, and R, which is minus 14 minus 14. That is given to us. We just found these 2 points, Q minus 5 minus 1. Now m was minus 2 and minus 5, and this is s, which is 1 minus 9. Right. Those are the points which we have. Now equation of diagonals and equation of the sides of the kite. So I'll just do diagonals equation. These two, this is perpendicular, you do the sides. So let's write down the equation of RP, major diagonal. Slope, we just found the slope actually. Slope of RP, you can again find y2 minus y1 over x2 minus x1. So in this case, it is minus 2. You can use this point, plus 14 over 2 plus 14, because when you do minus of minus, you get that. So that is equal to 12 over 16, or dividing by 4, 3 over 4. And therefore the equation y will be the slope 3 over 4x plus b. To find the value of y, we can actually substitute one of the points. 2 minus 2 is a good point. So write here 2 minus 2 as y value equals to 3 over 4 times 2 plus b. So that gives you the value of b as equal to minus 2 minus 3 over 2, which is minus 2 to 4, 4 minus 4 and 3, 7. And so we have this equation as y equals to 3 over 4x minus 7 over 2. Correct? That is one diagonal. Now the equation of the second diagonal is what? So that is the second diagonal. We know that the slope of QS is perpendicular to the other line, right? So perpendicular slope will be negative 4 over 3, right? So we'll take the negative reciprocal, and we have a point M on this, which is minus 2 minus 5. We are going to use this point. So we know y is equal to minus 4 over 3 x plus b. Substituting this point here, we get minus 5 equals to minus 4 over 3 times minus 2 plus b, correct? So now taking it to the right side, we have minus 5, that becomes negative 8 over 3 is equal to b. This is equal to minus 15, and minus 8 is 23 over 3. So we get the value of b, and therefore the equation of the line will be y equals to minus 4 over 3 x minus 23 over 3. So that becomes the equation of your diagonals. So what I did here was we found the equation of the diagonals. Equation of the sides of the kite, which is RQ and RP and all these sides, for you to do. So you do it. So this is for you. Use this concept of lines given 2 points to find the equation, correct? Now let's move on and do the other part, which is area of the cord needed to make the kite and total length of the bamboo required for the structure. We're almost at the end. Now let us find area and perimeter of the kite. So let me once again sketch the kite. So that is how we were sketching it. That's the longer diagonal. That's the shorter one. Both the diagonals are at right angles. Now we have already found all the coordinate points. So we have the values. This is R, which is minus 14 minus 14. That is P, which is 2 minus 2. We found Q as minus 5 1 minus 1. S as 1 minus 9. We also find M. Now, we need to find the area of the kite. Now, it is interesting to see that area of the kite is half of the product of the diagonals, right? So let's write area, which is half of RP times QS. It is a very simple proof, half base into height, and these two are congruent, so it becomes again half base into height, and so you get this formula, right? So basically, let's find the lengths of the diagonals to find the area. So R to P, distance from R to P is square root of x values difference, which is 2 minus 14 will give us that, plus minus 2 plus 14 whole square. Now that distance is 16 square plus 12 square square root. Now 16 square plus 12 square root is 20. Let's use calculator either way to just confirm our answer, which is equal to 20. So we know this length is 20 now for us. Since we also know that the ratio is 3:1, we can divide into 4 equal parts. So if you do that, we get this as 5 and that as 15. Okay? So that is the ratio. Now we are also given that these sides are equal. So that means these are also 5 and 5. Correct? So from one calculation, which is the major diagonal, we can get all other sides, since we know that RP, it is in the ratio of this, right? 3:1. So now we know the area is equal to half of 20 times the other one, which is 10. So which is 100 units square. Is that clear to you? So that much of card is needed. So the card needed will be 100 units square. Now let's find the perimeter. Since this is a right angle triangle, we can find QP as equal to 5 square plus 5 square root, which is, you can take 5 outside, square root 2. And similarly, QR will be square root of 15 square plus 5 square root. Now here also you can take 5 square outside, which becomes 5. 9 square plus this becomes square root of 10. So we know these two sides. So now we need bamboo required, right? So bamboo required will be what? Now when you are saying bamboo required, then we are also adding the diagonals, correct? So which will be basically, we have to add all the sides. So it is 2 times RQR plus QP plus this length, which is RP, plus the other diagonal, which is QS. Right? So which is 2 times 5 square root 2 plus 5 square root 10 plus 20 plus 10. Okay? So that is the total length required. We can always use calculator to find this. So it is 2 within brackets, we have 5 square root 2 plus 5 square root 10, bracket close. Let's find this and we'll add 30 to it. So that gives us 75.76 units. Okay, so you can approximate to 76 units. Is that clear to you? So that is how we can find the requirement for bamboo also. So I hope it makes sense. So we began with the brilliant question in which we found many things. So let's get back and have a look at what we did here. To start with, we actually derived the section formula and then we found the point M using the ratio 3:1. Once we found the point M, then we also learned a neat technique of finding Q and S, the other 2 points, right? So we used section formula to find M. Once we had the value of M, we actually found the value of Q and S using the property that they are at diagonals to one another. And we got the point of Q and S without using any distance or line formula. Do you see that beauty? Once we get all the coordinates, then it became easy for us to find the equations of the diagonals, the portion to find equation of the sides or edges was left for you. And finally, we found the area and perimeter. So I hope you understand and appreciate the things which you should know about the kite. This is indeed a very beautiful example, since here we learn almost every property of kite. Once again, thanks a lot for sharing such a beautiful question. I hope you all enjoyed. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.